Sometimes we run into situations when we're solving radical equations where there's more than one radical expression. So if an equation contains two radical expressions, that cannot be combined. So if we have something like the square root of 3x and the square root of 3x, we can combine those. Those would be considered like terms. However, if I have something like the square root of 3x plus 2 and the square root of 2x plus 7, those are not like terms. So we want to just pick one radical to isolate. Also, another thing we need to know when dealing with these is if we have an expression raised to the power 1/2, the power 1/2 is the same thing as a square root. We will get more into detail in terms of what, and I think I alluded to it in the last video if I remember correctly, in terms of exactly what do fractional exponents mean. But for now, all I need you to know is that if you have something raised to the 1/2 exponent or the power 1/2, those two sayings mean the same thing. It's the same as a square root. So let's go ahead and start. So on example 1, and I believe there's 3 examples, on example 1, first thing I notice is these are not like terms since they're not the same radical part. So I'm going to try to get one of these radical parts by itself. So let's say I try to get the square root of 3x plus 2 by itself. I'll get rid of minus square root of 2x plus 7 by adding it to both sides. And after doing that, I have now the square root of 3x plus 2 equals the square root of 2x plus 7. Now from here I can go ahead and get rid of my radical now that I've isolated my radical just like I did in the last video. So remember, I get rid of radicals by squaring. So squaring gets rid of a square root, so I'll square both sides. When I do, my square and my radical cancel, giving me 3x plus 2 equals 2x plus 7. This has now just become a very basic linear equation, so I can subtract 2x from both sides, giving me x plus 2 equals 7, subtract 2, and I get x equals 5. I want to make sure my solution works, so I check it, and I get 3 times 5 plus 2 minus square root of 2 times 5 plus 7. I want to know, does that equal 0? I always plug back into my original equation, always, always, always. Well, that gives me the square root of 17 minus the square root of 17. That will equal 0, so it checks out, so x equals 5 is my only solution. Looking at the next one. Now I have 6 times the square root of 5x minus 8 minus 18 equals 3 times the square root of 5x minus 8. Well, first thing I notice is that I have two radicals, so my initial thought is, oh, I almost have this one isolated. I can just divide both sides by 3. But then before I do that, I take a closer look and I realize that these are the same radicals, which means these are like terms. So I'm going to go ahead and combine my like terms. So I'm going to subtract 3 times the square root of 5x minus 8 from here. And then I will also subtract it from here since they're like terms, giving me 3 times the square root of 5x minus 8 minus 18 equals 0. Now I only have one radical, so now it's very similar to the previous video. So I'll isolate this radical by first getting rid of add or subtract. So I'll add 18 to both sides, giving me 3 times the square root of 5x minus 8 equals 18. I'll divide by 3, and I get the square root of 5x minus 8 equals 6. From here, now that I have the radical all by itself, I can get rid of the radical by squaring both sides. When I square my left side, the radical and square cancel, giving me 5x minus 8. 6 squared, remember, is 6 times 6, so 36. So then from here I can add 8 to both sides, and I'm going to need to have a little more room, so I'm going to come up here, and I'll have 5x minus 8 equals 36, so plus 8, leaving me with 5x equals 44. I divide by 5, and I get x equals 44/5. I do want to check my solution, so I'm going to plug that back into my original equation. Before I do, I'm going to give myself a little more room. And then that is going to give me 6 times the square root of 5 times 44/5 minus 8 minus 18. I want to know, does that equal 3 times the square root of 5 times 44/5 minus 8? Well, my 5's cancel under both my radicals, so that makes that a lot easier. And I get 6 times 44 minus 8 is 36. minus 18, does that equal 3 times square root of 36? So I get 6 times 6 is 36 minus 18. Does that equal 3 times 6, which is 18? 36 minus 18 does equal 18, so that checks out, and here is my only solution. Moving on to the last example. So very first thing I'm going to notice on that last example is I recognize that the 0.5 and the 1/2 mean the same thing. They mean the square root. So again, an exponent of 1/2 means the same thing as square root. So I'm going to start by rewriting this as 2x plus 1 equals the square root of 3x plus 4. Now that I have two radicals, the first thing I see is that I want to isolate one of the radicals. Well, that's easy. This radical here on the left is already by itself. Consequently, so is the one on the right, but I really only need one of them to be by themselves. So I square both sides. My squares cancel. After I cancel out my squares, I'm left with 2x plus 1 equals 3x plus 4. I'm going to subtract 2x. And I get 1 equals, I can say 1x, but 1x is the same thing as just x. So x plus 4. I'll subtract the 4. And I get negative 3 equals x. I will plug it back into my original problem. I'm going to leave, though, my square root, since we haven't talked a lot about fractional exponents. So since these mean the same thing, this and this, I'm going to go ahead and just plug into my second one. And now I'm going to, like I said, plug into my equation. I get 2 times negative 3 plus 1. Does it equal 3 times negative 3 plus 4? Which gives me negative 6 plus 1, negative 9 plus 4, and I get the square root of negative 5 equals the square root of negative 5. However, I cannot have negatives under my radical. So if I come back up here, I'm going to add that to my list. No negatives under a square root. What happens is that gives me imaginary numbers. We're going to start talking about imaginary numbers in our next unit. So for right now, all I'm going to say is because negative 3 gave me an imaginary solution, that's going to be extraneous, and I'm going to have no real solutions, or no solutions. So that's it. So just again, remember that these key things. Check to make sure your radicals can't be combined like they could in example 2. If they can't be combined, get one of the radicals by itself, then go through the same steps as you went through when there was only one radical. And if something is raised to the 1/2 power, please make sure you understand that that is the same thing as the square root, or 0.5, since 0.5 is the same thing as 1/2.